Let's get together to co-create a breakthrough for freedom of energy, sustenance, healing, and regeneration of the human vessel. Welcome to FESIG, the Free Energy Special Interest Group, where science meets spirituality in the quest for truth and knowledge to free humanity and transform this planet into a paradise. Hi everyone, welcome to FESIG 79th meeting. Today is the 5th of August. We are having our 79th meeting with our special speaker, Mr. Paul Townley today. Right, okay, I'm gonna share screen to show the agenda for today. Just give me a moment. All right, so here we are. We are now looking at the agenda of FESIG 79th meeting, which has this agenda here. FESIG, of course, is the Free Energy Special Interest Group. It is a platform where science meets spirituality, where we all gather to explore and learn and share ideas and develop our free energy devices. So, okay, the first session speaker is Paul Townley. Paul Townley has made some sensations these days because he has successfully developed some of Tesla's patents. He's gotten hold of Tesla's patents, and he's hoping to set up a museum here in England, showcasing Tesla's inventions. Paul will disclose how Nikola Tesla's machines were geared into the invisible evaporation cycle, the largest solar heat engine in the world, amongst so many other things that he will be talking about that he has been personally developing himself, which will be a very exciting time. And then having done that, after the Q&A session, then we adjourn to the second session where we will, as a group in FESIG, be conducting FESIG's memorial service for Patrick Kelly. And it is so sad that Patrick, whose real name is Edward Dixon Williams, has, I guess, unexpectedly passed away suddenly on Saturday, on the 11th of July, 2020. As we all know, Patrick was the author of the Practical Guide to Free Energy Devices, which inspired many people to research free energy devices and provides an extensive overview of the subject. He is a pillar of free energy development in the world. Unfortunately, he's no longer with us, but his work remains. And having done all that, then the meeting will adjourn to the 80th FESIG meeting on the 2nd of September. The speakers are to be confirmed. Okay, so this is, if you want to write to me, write to crystal@truevisionofpeace.com, and our website is truevisionofpeace.com/FESIG, FESIG, Free Energy Special Interest Group.html. Thank you. All right, so I'm going to introduce Paul Townley. I will introduce him properly. If you would bear with me, I am going to call up. Paul Townley has been interested in engineering and computer-aided design since 1994, when he studied manufacturing and engineering at school. Paul is a perfectionist, car enthusiast, who is a very methodical and meticulous worker. He started in the motor trade in 1997 as a Peugeot technician apprentice. He has since served in the roles of Jaguar technician, BMW technician, Ford technician, Renault technician, Royal Navy aircraft engineer, Green Flag, and AA Patrol. And 2010, Paul became fascinated by alternative energy after learning about Nikola Tesla's achievements. In October 2018, Paul's research and development of frictionless permanent magnetic bearings started a new era when Paul decided to devote his working life to developing a two-stage Tesla turbine and vacuum pump after discovering Nikola Tesla was also using frictionless bearings. This area of research and development opened up a Hansel and Gretel trail of unimaginable possibilities, of which Paul is very happy to share with the world in an open source fashion. Paul actually had spoken at FESIG 72nd meeting in January the 8th. He was talking about cold steam, turbine frictionless bearings. Today, he will be talking about so many other areas of interest. So without much ado, over to you, Paul. Would you take over
Thank you very much for the lovely intro, Crystal. Thank you for having me back again. It's very appreciated. And thanks for giving your time to listen to me again. Yeah, I just wanted to start off really with going into a bit of the deeper history of the roots of where Tesla got his inspiration from and how he got from where he started to where he ended up. So I'm going to start with a screen share, if that's okay.
Okay, carry on.
Right. I'm just going to open the British patent.
Wrong page. Yeah, okay.
So a lot of people don't realise that the British patents are not actually the same as the American patents, and therefore they're overlooked completely. Also, there's British patents that don't exist anywhere else. I think this is because Tesla wasn't getting any sort of problem from the British Patent Office. So he decided that this was the place where he was going to unload some other information that he wasn't going to unload anywhere else. I'm just going to go down. I'm just going to highlight it here. It says here, I'm aware that it has already been proposed to effect atomizing by dropping a liquid on a plate rotating about a substantially vertical axis, and I make no claim to the arrangement. Now, at the bottom of the patent, he left the next clue, where it's got reference has been directed in pursuance of Section 7, subsection 4 of the Patents and Design Act 1907 to specification number 696 of 1867. Now, I managed to obtain this patent from the British Patent Office, and it's really interesting actually that it was a device that was fitted to Queen Victoria's ship called the Water Witch, and nobody knew how this ship was able to go at such high speeds, and it was using the same principles of what this patent's called. And the patent is called Improved Method of Imparting Energy to or Deriving Energy from a Fluid and Apparatus for Use therein. The patent from 1867 has almost got the same name as that. The next thing that I want to draw attention to is I've got a community page on my website, and I use this for teaching. And I'm just bringing you back to this is an article in 1919, My Inventions by Nikola Tesla. It was in the Electrical Experimenter, and these paragraphs of where Nikola Tesla conceived his idea. It said, in the second year at that institution, I became obsessed with the idea of producing continuous motion through steady air pressure. The pump incident of which I have told had set afire my youthful imagination and impressed me with the boundless abilities of vacuum. I grew frantic in my desire to harness this inexhaustible energy, but for a long time I was groping in the dark. Finally, however, my endeavours crystallised in an invention which was to enable me to achieve what no other mortal ever attempted. Imagine a cylinder freely rotatable on two bearings and partly surrounded by a rectangular trough which fits it perfectly. The open side of the trough is closed by a partition so that the cylindrical segment within the enclosures divides the latter into the two compartments entirely separated from each other by airtight sliding joints. One of these compartments being sealed and once for all exhausted, the other remaining open, a perpetual rotation of the cylinder will result, at least I thought so. A wooden model was constructed and fitted with infinite care, and when I applied the pump on one side and actually observed that there was a tendency to turning, I was delirious with joy. Mechanical flight was one thing that I wanted to accomplish, although still under the discouraging recollection of a bad fall I sustained by jumping with an umbrella from the top of a building. Every day I used to transport myself through the air to distant regions, but could not understand just how I managed to do it. Now I had something concrete, a flying machine with nothing more than a rotating shaft, flapping wings and a vacuum of unlimited power. From that time on, I made my daily excursions in a vehicle of comfort and luxury as might have benefited King Solomon. It took years before I understood that the atmospheric pressure acted at right angles to the surface of the cylinder, and that the slight rotary effect I observed was due to a leak. Though this knowledge came gradually, it gave me quite a painful shock. And I was just left with, there's a photograph here, and this was the most powerful Tesla turbine that we've got a photograph of. It's suggested it's actually 10,000 horsepower. Yeah, I've got another article here. I won't read all of it. But I've just chopped out a section of it, and it's called Tesla's New System of Fluid Propulsion. The Tesla turbine, by virtue of its exceptional heat resisting and other unique properties, makes possible the attainment of a great fuel economy, but with a single stage, incidentally offering the additional advantages of an extremely small, compact and reliable mechanism. But perhaps the chief commercial value of this new prime mover will be found in the fact that it can be operated with the cheapest grade of crude oil, colloidal fuel or powdered coal, containing considerable quantities of grit, sulfur and other impurities, thus enabling vast sums of money to be saved annually in the production of power from fuel. There's some expressions of opinion on the Tesla turbine. I haven't really been seen or published in many places. C.B. Richards, Professor Emeritus of Mechanics, Yale University. I am amazed at the development of power given by the turbine and stunned by the exhibit. F. Sargent, Chief Engineer and Turbine Expert. I'm impressed with the newness and novelty of the underlying principle of this invention. It is such as will claim the attention and admiration of anyone of a scientific turn of mind in a mechanical direction. Reynold Janney, Chief Engineer, Universal Transmission Company, is a great invention. Brigadier Allen of the War Department, something new in the world. Officers are greatly impressed with it. Miller Reese Hutchinson, Chief Engineer, it is the greatest invention of the age. Arnold Trini, Chief Engineer, I'm not going to read that. The ideal of the turbine engine. BRT, Colline, power plant economist, it is a wonderful turbine. The motor world, the new principle, unquestionably, is a great contribution to science and engineering, great in its simplicity and breadth of application. Scientific American, considered from the mechanical standpoint, the turbine is astonishingly simple and economical in construction, should prove to possess such a durability and freedom from wear and breakdown as to place it in these respects far in advance of any type of steam or gas motor of the present day. Engineering magazine, an entirely new form of prime mover with interesting possibilities. Technical World magazine, the Tesla turbine is the apotheosis of simplicity. It is so violently opposed to all precedent that it seems unbelievable. From numerous articles and comments, the turbine is different in principle to any heretofore in use, and one which will take less room and less coal than the best engine now running. Turbine of revolutionary design, improvements in dynamics which promises revolutionary results. Results seem revolutionary to the point of staggering the imagination. This motor will revolutionise the turbine industry. Wonderful motor, extraordinary mechanical principle. And I just left that with one of my favourite quotes. The scientific man does not aim at an immediate result. He does not expect that his advanced ideas will be readily taken up. His work is like that of a planter for the future. His duty to lay the foundation of those who are to come and point the way. Now, I kind of see it as my my role in this is I'm the guy that came and pointed the way. Because others
have... funny, you see, because these are the very deep muscles of the back, and these are the deep intrinsic muscles of the back.
He's cute.
Where's that sound coming from?
Of intrinsic muscles of the back and things like that. Okay, don't get hung up on the terminology. Okay, the most important things to remember then.
Pontus, can you find that?
Yeah.
Thank you.
That was a bit weird.
Yeah.
I thought it was my computer.
No.
Yeah. Thank you, Paul. Go ahead.
Yeah.
Okay. Yeah, I've prepared. I didn't really have like Crystal. Me and Crystal didn't speak that long ago, so I've not had masses of time to prepare. But I have prepared some stuff that I want to go over.
Right.
Mainly stuff that's kind of unknown, really. It's because the British patents weren't found until 1998. And the US patents were actually split into 4 patents. 2 patent applications were denied, whereas the British patent wasn't. So in this patent that I've got open now, which is the diagram from the British patent, there's actually 5 machines within this diagram. There's actually 5 machines. One of them's a hidden feature. The turbine is pretty well known. If this machine is made to run at supersonic speeds, then it opens up it basically taps into the evaporation cycle, which is invisible. That's one of the unknowns, but it's not actually possible to do that without frictionless bearings, because if you haven't got frictionless bearings, the heat from the ambient will be converted back to heat by the ball bearings. So it's like opening the front door and having the back door slam shut. The ball bearings of the back door slamming shut. If you want to keep the back door open and keep the draft going to harness the heat, then you've got to have frictionless bearings. So in this patent that I've got open, where I'm circling now, or where I'm highlighting now, the 2 inlets, if they're diverging nozzles, the machine will convert it will rapidly condense the water vapor in air to distill water. What will be exhausted from the exhaust here will be distilled water if the machine is running at supersonic. If you want more water, you open the tap more. If you want less more water, you shut the tap. The next feature of the machine is the rotary engine. Now, in order to turn the machine into a rotary engine, these 2 need to be straight ports. The byproduct of that is cold air and torque at the axle. The next one is the pump, which people are quite familiar with. The tear-shaped holes in the rotor allow this to be a pump. The one that isn't well known is the compressor. Now, if you make these discs solid, so there's no tear-shaped holes, then this is a Tesla compressor. So as the as the discs are rotating round, the spiral path is getting tighter and tighter and tighter, and the compressed air is propelled out of the exhaust, which actually pulls a vacuum. So the pump or the compressor will pull a vacuum, but the pump will give cold air, whereas the compressor will give compressed air. Compressed air generally, you know, the more compressed it is in a piston engine, there's a lot of friction to make it. So this isn't using friction by using a piston; it's using the spiral path getting tighter and tighter and tighter. Now, the next machine that isn't known is a hidden feature. One of Tesla's, I suppose you could say it was a secret there to be found if you replicated his machines, because each of his patents is actually it's a lesson. If you copy the text and copy the diagram, the words that don't make sense will make sense. So the first time I found any reference to this was in The Problem of Increasing Human Energy, which was written in 1900. Probably one of Tesla's most detailed articles. I've left there's a link there. I'm not sure how I can put that into the FESIG, but I'll carry on. Right, I won't read all of this, but I'll read some of it. I was vainly endeavouring to form an idea of how this might be accomplished when I read some statements from Carnot and Lord Kelvin, then Sir William Thomson, which virtually meant that it is impossible for an inanimate mechanism or self-acting machine to cool a portion of the medium below the temperature of the surrounding and operate by the heat abstracted. These statements interested me intensely. Evidently, a living being could do this very thing. And since the experiences of my early life, which I have related, had convinced me that a living being is only an automation, or otherwise stated, a self-acting engine, I came to the conclusion that it was possible to construct a machine which would do the same. As the first step towards this realization, I conceived the following mechanism. Right, this is the bit relating to the dynamo. Imagine a thermopile consisting of a number of bars of metal extending from the Earth to the outer space beyond the atmosphere. That's what this diagram is talking about. There's two bars extending from the Earth to the atmosphere. The heat from below, conducted upward along these metal bars, would cool the Earth or the sea or the air according to the location of the lower parts of the bars, and the result, as is well known, would be an electric current circulating in these bars. The two terminals of the thermopile could now be joined through an electric motor, and theoretically this motor would run on and on until the media below would be cooled down to the temperature of the outer space. This would be an inanimate engine which, to all evidence, would be cooling a portion of the medium below the temperature of the surrounding and operating by the heat abstracted. It goes into some detail about that diagram, and basically what he's doing is an analogy of how to turn atmospheric heat into electricity. I won't read the bit in green, but it says here in the yellow, heat, like water, can perform work in flowing down. And if we had any doubt as to whether we could derive energy from the medium by means of a thermopile, as before described, it would be dispelled by this analogue. But can we produce cold in a given portion of the space and cause the heat to flow in continually? To create such a sink or cold hole, as we might say, in the medium, would be equivalent to producing in the lake a space either empty or filled with something much lighter than water. Now, the next reference I found of the turbine is in fact a dynamo, is going back to actually Tesla's work in 1891. He's got an article called Notes on a Unipolar Dynamo by Nikola Tesla, and that was in the Electrical Engineer. This is the earliest reference I can find, and there's a couple of little bits I've highlighted where he says, we may explain the operation of such motor just as we can that of a water wheel. Another one is giving currents of one direction without the employment of commutating devices and at right angles, which was also discussed. I'm just going to open another link. This was the next reference I found that the machine's a dynamo, and this is called a lighting machine on novel principles. A machine built on novel and original lines is about to be placed on the market. It consists of a turbine and electrical generator, both employing basically new principles in construction as well as operation, and intimately associated to constitute a unit. The former has been pronounced revolutionary in its design and performance. It is simplicity itself, being devoid of buckets, deflecting blades, guide passages, vanes, and the like, and presents many other decisive advantages of the ordinary prime mover. A bit further down, but the merits of this lighting outfit do not rest on the turbine alone. The dynamo associated with the same is perhaps equally noteworthy by its simplicity of construction, high efficiency, and rare and valuable properties it possesses. It consists of a smooth cylindrical body mounted on the turbine shaft and arranged to rotate within a magnetic field of novel former. There is no brush or sliding contact whatever. The current being taken from stationary terminals to which the ends of the generating coils are connected. Right, I'm not going to read all of that, but I'm just going to go back to my back to this. And this article on Notes on Unipolar Dynamo by Nikola Tesla has got diagrams, and I mean you can see that's somewhat similar to Faraday's disc and also a Tesla turbine. And it's quite an interesting one to read. I'm not going to read it all out, but I wanted to point it out. How Tesla was able to make the turbine cold and create that heat sink that was spoken about is by making the turbine supersonic using frictionless bearings. Tesla's only drawing that he ever left to do with frictionless bearings was left in British patent 179043, and number 9, which is there and there. Number 9 is in the description is bearings, and he was able to do this by using ultra tight tolerance gaps. I'm going to show you that now, how that was done, and it also it's also something that he used for his earthquake machine, his mechanical oscillator. So I'll show you a video of some very tight tolerance air bearings. Not going to watch the whole video, I'm just going to find the bit that's relevant. This guy's called Dan Galbert.
This is Dan Galbert with a short video.
Probably one of the most talented machinists in the world. He actually made this lathe and grinder, precision grinder. It runs on air bearings, and it can actually machine 1 micron tolerances. So I'm just going to find that bit that I was going to show you.
Here is a cylinder and a piston which is made on this lathe, and you can see that the piston is a complete sliding fit in the cylinder. It's completely loose fit. Now if I seal off the air vent on top, you can see it's completely airtight. And another nice property, because it's so accurate, if I spin it, it spins freely as if it's on ball bearings, but it spins like a self-acting air bearing. And the same is true if I spin the inner piece, it will spin frictionlessly for a long time. So in other words, if you made a bearing like this bearing will never need lubrication and never wear out, because there is no contact between the inner part and the outer part. You can verify that with an ohm meter while they turn. It's the same idea as air bearing in a hard drive or air bearings in other self-acting air bearings devices. So this is one example of a part that, if to do it without a machine like this, you'll have to do it by time-consuming lapping, and it will be quite hard to get parts to fit to that tolerance. On this machine, it comes out like this straight off the machine. So now let's go over the piece by piece.
Right, I'm just going to show you that's using 1 micron tolerances. So it appears Tesla was able to achieve some very tight tolerances even back then. I've got a feeling he was, building his own machines with his machinist, and of course he was able to afford the best machinist that existed. This is another process that uses slightly less. This uses 8 micron tolerances and a surface treatment.
Hi, I'm Mike Kojima, and I'm the engineering editor for MotoIQ.com, and we're here at WPC Metal Treatment today, and I'm with Izumi Ogawa from WPC, and we wanted to kind of show some quick little demonstration of some of WPC's properties. Now, WPC isn't a coating, but it's a metal surface treatment, and the process actually modifies the surface of your part for better fatigue strength and less friction. It doesn't change the clearances or the geometry of the part at all. Like, we've measured things very carefully, and even delicate metal surfaces, it doesn't distort or change the surface at all. So it's perfectly safe on things like bores and close tolerance grooves and complicated geometries. It won't change fits or tolerances. And we kind of wanted to demonstrate the anti-friction properties, and Izumi here has it's a ground steel rod and a cylinder with a bore, and this is like a ground with a honed ID, so the tolerances are pretty close. The clearance between this part and this part is 3/10,000ths of an inch, which isn't like crazy. I mean, it's looser than a typical piston pin fit, for instance. And as you can see, the pin here, this is WPC treated, and this is the regular finish. If you like rub your nail, like, you cannot feel any difference at all. And if you put a micrometer on here, there wouldn't be any difference. So, Izumi-san, why don't you show what WPC can do?
Okay. Spin like this. It's like air bearing. There's no lubrication, and it seals better. So if I push and spin, it spins like this. It's floating.
Yeah, it's spinning and sealing, and the clearance is not like a particularly super tight clearance, so that's pretty amazing, I think. No lubrication either.
So Tesla in Tesla's vacuum pump, he was using something similar here, but at the same time, the rotor spinning was allowing atmospheric pressure to rush in and fill that ultra tight gap that was on this side and this side. So it was a combination of the effects that I've just shown you and using atmospheric pressure to support the weight of the rotor. This is called an aerodynamic bearing, and there's another type that I'd like to show you. This is an off-the-shelf air bearing. It's an aerostatic bearing that anyone can buy. They're not particularly cheap, but when you're dealing with this level of precision, you're going to pay for it. So the tolerance on this is about 17 microns between the shaft and the thrust air bearing. This particular one's got, I'm going to mute it. This particular one's got two shaft collars that are fixed to the shaft. If this was used in a Tesla turbine application, the casing would have to replace the shaft collars, and the rotor at the other end. Or you could have the bearings internally or externally. But yeah, so there's one more type of aerodynamic bearing that I'd like to show you, and that's called a foil bearing. This is actually an English company. What's actually happening with these is they're not frictionless from the start. The faster they spin, there's a pattern, I'll show you in a minute, that pushes the bearing away from the shaft. This is the type of bearing that's used on modern turbo machinery, and they use on modern turbo machinery. And here's hang on. Here's the type of thing that these aerodynamic bearings. This is the type of way that they achieve it. Is they have this herringbone pattern that's etched into the shaft at about 5 to 20 microns depth, and as the shaft is spun, it pushes the bearing away. For the radial load, this one, and for the actual load, this herringbone pattern on this one. So that what it does is it actually creates compressed air, and this is the modern aerodynamic bearing. What Tesla was doing, this is the museum version with all the brass pipeworks. So in order to start this machine, this is the exhaust here, and this is the inlet at the top. So this device here allows you to switch between clockwise or anti-clockwise. So it can also be used as a brake to stop the machine. And then the bearings are housed inside here. These egg shapes are have like matching housings with an air gap, and the air is plumbed from the exhaust housing into here, both ways. And this is some other shots from the museum. This is the back. This is the back side. So you can see the pipes going in and the pipes going out. So that each bearing's got an in and an out, or an in and an out. There's probably airflow actually both ways. If you could see it. This museum device, it's quite interesting. It's been disabled by they've actually cut a section. I think Tesla had a section cut out of it. I don't think the museum did it. So if that section was repaired and a large vacuum pump was applied to the exhaust here, atmospheric pressure would rush in through the inlet, and it would levitate the shaft and the rotor, and that's how this rotor was designed to be started, using high vacuum. This was Tesla's later design. This is his 1921 design, whereas this is Tesla's 1911 design. So these are aerostatic bearings that are available off the shelf. That you can literally incorporate these straight into a Tesla turbine. I'm actually working with a engineering team based in Sweden who have a family business engineering company, and I've actually ordered a set of these bearings here to those guys, and they're building one of my latest designs. The company that manufactures these air thrust bearings is called OAV. There's 3 porous carbon media air bearing companies, and strangely they're all in America. And they're working to a quarter of a to this level of precision that's here, which actually looks like not a quarter of a micron, which was what I first thought it was. But yeah, I mean, that big green bit is 90 microns, and a white blood cell is 25.4 microns. That's that one. Bacteria is 2 microns. That's that one. That's 1 micron, and this is the level of precision that they're working to with these components. And this is a number of products that they make. This is the only company I've found with a ready-to-go air bearing that can be used for a Tesla turbine. The downside is they need compressed air, and I did have a go at manufacturing some, and what was found was that
Hi folks,
so
just a little
I won't play all of this. What was found is that the surface area, I've just turned the air on, the surface area of the shaft and the surface area of the bearing has to be sufficient enough to hold the weight of the rotor and the axle. What I did since this one, Graham, who's also part of FESIG, helped me refine the design on this. What was discovered is if you put your finger over the end of the air bearing, it all of a sudden becomes a lot more powerful. But the downside to these is you need air, you need compressed air. So for a minute, I've shelved this design, and what I've done is I've now got a permanent magnetic bearing design. This isn't actually the finished version, but it kind of give you a clue. I'll just zoom in a little bit. So there's a magnet housing, two magnet housings, one here, one here. The new one's going to have some very low, these are just 1 kilo magnets in here. There's just one in each end to stop it moving left and right. And then in each magnet housing, there's actually 12 magnets. There's 12 magnets, but times 3. So what I found out is the perfect shape it appears for a permanent magnetic bearing is actually an equilateral triangle. And the reason for that is if the shaft, here's the shaft here, if the shaft is, you're looking at the side view, basically that there's only one set of magnets pushing down and 2 sets of magnets pushing up. So this design works very well for a horizontal axle or for a vertical axle, whereas my latest video, which I'm just going to show you some of now. I'm not going to play all of this either because it's quite long. But my latest video, what's wrong with this design is there's no opposing magnet there. This aluminium bit here is just used as a weight. Now you can tell this is frictionless because it will spin backwards and forwards like that. That's how you can always tell if a shaft's frictionless, especially if there's a heavy spot. I mean, you can easily put a bit of blue tack onto a shaft, and if it spins around backwards and forwards like that, it's definitely frictionless. So the weight that's on that needle point there, if you put it on a scale, it would be next to nothing. It's just using it to stop it throwing it to the left. Because I'm just going to go forward a little bit more. There's 6 magnets on the shaft there. These are nylon washers. All this metal this is all aluminium. The shaft's stainless 316 because it's not very magnetic. The point and where it touches is hardened tool steel. There's actually 36 magnets in this housing, and there's 36 magnets in this housing, but it's 6 by 6. There's 6 lots. There's 6 lots in here of 6, whereas the new design, this one, there's actually there's 3 lots of 12. So with permanent magnetic bearings or air bearings, the longer the air bearing or longer the permanent magnetic bearing, the more magnets there are in a row, the more stable the X and Y axis is going to be, and that's quite important because if you want to use magnets for repulsion if you want to use magnets for repulsion on the end of the shaft, then you can't have powerful magnets here because magnets in attraction will pull together and they'll pull to center. I'll show you an older video I've got, and it's going way back now. So this particular version of a magnetic bearing has got a 120 kilo magnet here, one here, one here, and one here. These are all in attraction because they all pull to the dead center. It's not completely frictionless though, and it's not really tunable. All you can do on this one is tune this in and out, and that's it really for the tunability. And the problem is with this design is 120 kilo magnets are really scary to work with. That it's like having a loaded gun. It's more dangerous than a loaded gun. Whereas with this design, the side view's better. The magnet in here can be adjusted in and out. There's a hole here, so you can put a screwdriver in and wind the magnet in and out, and you can do the same this side. And the aim of the game is to actually align all the magnets on the shaft with all the magnets in the housing. When you get dead center, it's a fine point of tuning. The shaft's not trying to throw itself left or throw itself right. There's an equilibrium point, and you can only achieve it with either two needle points on each end, or what I'm trying with this new design is I'm trying to use two magnets in repulsion. I'll just find a video, a bit of that where it's actually spinning. Hang on. There you go. You can see it's got a bit of buoyancy here, but the weight isn't in the center and it's not balanced. And yeah, you can see like, you know, it's not taking really much effort for it to spin. So when you've got a frictionless bearing and a Tesla turbine, and you create that draft, just like when you open the front door and the back door slams shut, the frictionless bearing is throwing the block of wood in the gap in the door and keeping that draft open, and it's the draft that we're harnessing. So yeah, I think that's kind of it for now on the magnetic bearing. I wanted to show you some of Tesla's other stuff that I've been working on that you might not have come across. The first is the hovercraft. Not sure if anyone's seen this before. Nikola Tesla's got a hovercraft, and it dates back to 1908. Now, it's not a particularly good quality drawing, and it's a little bit hard to wrap your head around if you only just starting to understand the capability of what a Tesla turbine can do when running supersonic. This is a water tank, and this is a gas tank. Now, you might think, oh, why has it got a big water tank and why has it got a big gas tank? You know, is it going to run on water or is it going to run on gas? Now, it's actually this is the starter motor. These form part of the starter motor, and there's some bits that aren't fully shown. You can just about make out there's a man or a woman sitting on the hovercraft there, and this is a seat. That's a seat there, and this bit here is actually it looks to me like it's a two-stage turbine and pump. There's some arrows which you can barely see. There's an arrow coming in there and there, and arrows going out there and there, and arrows coming in there and there, and then arrows going out. So how this would work, it kind of works, and I'll show you a video, and so you can understand kind of like the principle of if all of the flow was going in one direction, what it would look like. I won't play all the video, but I'll just fast forward. So you can see the flow. The flow is coming out like in two paths like that. Now imagine if the flow was just going in one direction, the flow would be coming out of here, and if it was at supersonic, it would be air mass that's coming out. This doesn't work like a jet engine. It works using air mass rather than air velocity, which is also how Tesla's flying machine works. This is Tesla's flying machine patent drawing, Fig 3, Fig 4, and Fig 5. Now this is Tesla's final. It was his final ever US patent that was ever approved. There's an interesting story behind this, because if you go to right, this was Tesla's patent application, or Tesla's patent in, if you look at the date of, it was filed in September 9th, 1921, and in Great Britain in April 1st, 1921. Now, if you look here, the patent wasn't granted until January 3rd, 1928. And if you look at the number here, 1655113, I'll just scroll down to the patent diagrams. You'll notice in this particular area here and here, there's no fuel tank. There's no fuel tank at all. Number two is a turbine, and a turbine. This is a twin. It's a twin turbine design, and if I then go to US patent 114, if you look at the dates, application filed October 4th, 1927, patent granted January 3rd, 1928, and the patent numbers 1655114. So Tesla had to submit this as an, it says here, this application is a continuation in part of my application serial number 499518, filed September 9th, 1921, and is made pursuant to the rules of the Patent Office, its purpose being to describe and claim apparatus which I have invented for carrying into practice the method therein disclosed. Now, what that means is that the Patent Office denied the patent application in 1921 because it didn't have a fuel tank. But then the French, and the British patent, and there's some more. There's an Italian one. I've not got hold of that yet. And I think there's some more as well, that never had a fuel tank. So if you look at this one, number 17 wasn't there in the previous one, and then out of the twin turbines now you've got an exhaust coming out that wasn't there before. So you got there's the fuel tank and the exhaust. But then if you read the patent description, it says here in figure 3, this apparatus is diagrammatically indicated by 17 and may be one of any number of well-known types producing pressure by internal combustion or of suitable fuel, or by an external firing of a steam boiler. Now, the steam boiler is interesting because I figured out that I figured out that Tesla's valvular conduit patent, figure yeah, I haven't got if I can rotate that. figure 4, this here, this device on the top is actually a low pressure superheated steam boiler, and I've actually replicated that. I've got a working replication of it, and what Tesla was talking about in the previous patent, where he's talking about firing of a steam boiler, the number 17, as this is Tesla's final design, Tesla showed how to incorporate, there's 17, how to incorporate a steam boiler, which is actually a pulse detonation engine. And I'm just going to get that back up. Hang on. Oops. Yeah, the valvular conduit patent is a very interesting patent, actually, because there's a bit of a history behind it that a lot of people don't know about. It was originally submitted in February 21st, 1916, and if you notice, it didn't get approved until February 3rd, 1920. There was actually, it was kicked back, and Tesla had to take some information out because it conflicted with another inventor's work. I found out that from the 33 denied patent applications book that I got from the museum. And in this diagram, it seems that a lot of people have given full attention to figure 1 and figure 2, and there's various different replications of people making a valvular conduit on YouTube. But they didn't really fully understand what it was supposed to be used for. And it's got 2 purposes in Tesla's machines. One is in this pulse detonation engine. I can tell you it's a detonation engine because if you search detonation, detonate, it does say a fresh mixture which is detonated as before. So there's another thing in here that's quite an interesting thing, and it says such a machine is a thermodynamic transformer of an activity surpassing by far that of any other prime mover, it being demonstrated in practice that each single disc of the rotor is capable of performing as much work as a whole bucket wheel. Yeah, I'm not going to read all of it. The other interesting thing which has been overlooked is figure 3. Now, figure 3 is actually Tesla's final design for his earthquake machine, his mechanical oscillator, which can be seen in, you might be familiar with this one. This is from February 1894, Nikola Tesla's reciprocating engine. This was his the first time he patented his mechanical oscillator to run off steam. And another secret with that was it would also run off atmospheric pressure. And this bit at the top, which would be this bit here, which would be moving up and down like a linear actuator, would be able to generate electricity using the opposite function of a linear motor, or move mechanical machinery with some strange mechanical contraptions. But this was the basis of Tesla's mechanical oscillator. This was his final design, which incorporates 2 valvular conduits, which actually turns this machine into either a pump or a compressor. So if I search pump, figure 3 is a diagram illustrative of the application of the device to a fluid propelling machine such as a reciprocating pump or compressor. So if I search, yeah, will result in a compression of the air at 4 and rarefaction of the same at 5. So what Tesla's basically saying is this machine here is a free energy device, once started, uses 2 valvular conduits to tap into the invisible evaporation cycle, and it can produce either vacuum or compressed air. This is the this mechanical oscillator is the piston version of the Tesla pump, or the Tesla compressor with the no tear shaped holes. And the mechanical oscillator is actually this one, and this one is actually Tesla's replication and improvement of Sadie Carnot, who the second law of thermodynamics is based on the work of Sadie Carnot. Yeah, if you don't know, Sadie Carnot was born in 1796 and died in 1832, so he wasn't particularly old. He was only 36, but he can. So in which he expressed at the age of 27 years the first successful theory in the maximum efficiency of heat engines. So the whole second law of thermodynamics falls back on a 27-year-old Sadie Carnot, who basically theorized a frictionless piston engine, whereas Nikola Tesla actually built the theoretical frictionless piston engine using the method that I showed you earlier of having ultra tight tolerances, so the piston and the cylinder become an air bearing, and then he refined it to make electricity or mechanical movement. But then Tesla realized that the part that was actually the weakest link in this was the piston, and the fact that it had got to go backwards and forward. It's got to keep making 180-degree reversals, and that is where the energy is lost. So Tesla then conceived the Tesla turbine and the Tesla pump as rotary engines to basically eliminate the 180-degree reversal. And yeah, so Sadie Carnot's work is still to this day reflected upon as the laws of thermodynamics, and Tesla's work on the reciprocating frictionless piston engine and the lost it now. Yeah, on the mechanical oscillator are completely unknown. This particular device, it does say in the patent that it does say this arrangement is familiar, being representative of a prime mover of my invention termed mechanical oscillator, for which it is practical to vibrate a system of considerable weight many thousand times per minute. Now, just to open a quick calculator, if you've got something going thousands of times a second, let's just say it's doing 2,000 times per second times 60. If that was a piston engine doing, if it could do 2,000 times per second, then that would be the equivalent of a 4-stroke engine doing 120,000 RPM. Yeah, so divide that by 2, that's 1,000. So an oscillation, a mechanical oscillator doing 1,000 RPM would be the equivalent of a piston engine doing 60,000 RPM. Now, if you look up highest RPM piston engine. Yeah, let's try Formula One. So about 20 Cosworth was able to achieve 20,000 RPM. Now, the reason why Tesla's reciprocating engine is able to do much higher RPM is, firstly, it doesn't need oil because it's using an air gap as the frictionless part. So if there's no contact between the two parts, then the oil's not getting, the heat isn't there. Also, there's no crankshaft on this device or this device. There's no crankshaft, and a crankshaft is kind of like the con rods and the crankshaft are the weakest link, really, in a high RPM. So back in 1894, Tesla had already bettered everything that exists in terms of the power that could be obtained, because this thing could oscillate at thousands of times a second. And then in 1906, when Tesla started working on this, his first patent was submitted in 1909. He then improved his own, he'd already replicated Sadie Carnot's design, but now he'd improved it. And then his final design for the vacuum pump, which is this is a 3-stage vacuum pump. This 12 is the inlet, the air goes in, gets centrifugally flung to the top here and the bottom here, slightly under compression, gets pushed, because this rotor, the Mark II rotor, what isn't also known is it's actually a combination of the effect from this one, because the tear-shaped holes chop the air, which stretches it, and then they smash the air out of the exhaust. Then with the no tear-shaped holes, the spiral path gets really tight and it compresses the air. When you come down to Tesla's final design for a vacuum pump, this rotor chops the air and smashes the air. It smashes the air and compresses it. So the air then goes into a second stage, which has then got finer tolerances between the discs, and then same again, gets smashed to the outside and compressed to the outside through centrifugal force, and then it goes into the third stage and then ejected from the third stage, which again has got even tighter gaps. I have actually found a reference, I'll see if I can find it, where Tesla describes that, let me think, Tesla tornado. Right, Tesla's got an article called Breaking Up Tornadoes. Very interesting article, and it's about, the article is about, here's a tornado. It's talking about that sailors tried to shoot a water cannon into tornadoes, but the water cannon, it was the right idea, but the water cannon wasn't powerful enough to disperse the tornado. So Tesla's talking about a radio controlled plane carrying explosives into a tornado to break it up. And yeah, there's a hangar housing tornado destroying planes. So basically all the tornadoes that happen in America, they don't need to happen, or wherever they happen in the world. I know there's quite a lot in America, but the reason why this is relevant is, hang on. here, look, in respect, its action may be likened to that of a multi-stage vacuum pump. So I'll read that from the thing at the start. The tornado whirl is a huge pump drawing air through the opening at the top and discharging it from the periphery rim at the same rate, simultaneously producing rarefaction in the interior. In this respect, its action may be likened to that of a multi-stage vacuum pump, for as the air rushes from the top of the base, more and more of it is drawn to the periphery, increasingly progressive the vacuum, which may thus attain a high value near the ground. This accounts for the gradual contraction of the whirl. What degree of rarefaction is actually reached in this monstrous contrivance of nature may be roughly estimated when considering that for any horizontal section of the funnel, the centrifugal force of the air is balanced by the opposingly directed differential pressure existing between the outside and the interior of the whirl. So this is basically Tesla's mechanical replication of a tornado, and that is the principle of the vacuum pump in this diagram, which was his final design. I've also found other references. I can't think where to search at the minute. Of this is actually the mechanical analog of Wardenclyffe. Yeah, I can't think where to search from at the minute, but I'll come back to that in a minute. So other stuff that I've got here, the flying machine that I was talking about earlier, it doesn't work like a normal flying machine. Normal flying machines move air at velocity and use the wings for lift. This is a different beast altogether. This twin turbine here, in his final design, he actually splits it into, this is the turbine here, because it's got the diverging nozzle, and this is the rotary engine, because it's got the straight port. Now, just to give you a reference of that, right, if I type in, right, so here it says here, in order to bring out a distinct, this is the US turbine pattern, by the way. In order to bring out a distinctive feature, assume in the first place that the motive medium is admitted to the disk chamber through a port. That is a channel which it transverses with nearly uniform velocity. In this case, the machine will operate as a rotary engine, the fluid continuously expanding on its tortuous path to the central outlet. The expansion takes place chiefly along the spiral path, for the spread inward is opposed by the centrifugal force due to the velocity of whirl and by the great resistance to radial exhaust. I'll jump a bit in the text. It says, next assume that the fluid is admitted to the disk chamber not through a port but a diverging nozzle, a device converted wholly or in part the expansive into velocity energy. The machine will then work rather like a turbine, absorbing the kinetic energy of kinetic momentum of the particles as they whirl with continuously decreasing speed to the exhaust. Now I'll just explain that in basic terms and also show you right at the top of the patent. It does say, be it known that I, Nikola Tesla, a citizen of the United States residing at New York in the county and state of New York, have invented certain new and useful improvements in rotary engines and turbines. Now, going back to this diagram here, which was Tesla's final flying machine design, this is the turbine because it's got a diverging nozzle. And this is also the only time, Tesla's final ever patent that was approved is the only time Tesla drew the nozzles and the port. And it shows you that the ideal mechanism for the diverging nozzle is a throttle body, which is the same as what you find on a petrol engine, number 16. What happens here, this is the steam boiler, superheated steam boiler, number 17, is that a diverging nozzle, as the as the heat comes into here, which is around about between about 600 degrees Celsius and 300 degrees Celsius, approximately about 1100 Fahrenheit to 650 Fahrenheit, roughly. As the heat comes into this nozzle, the diverging nozzle converts heat into velocity. So the hotter the gas, the vapor that comes into here, the faster it's accelerated. So that is what I understand. This part is used to make the machine move faster or slower. The circle there is actually the exhaust, and the shaft doesn't exist. The rotor in this is shaftless. It's shaftless, and the rotor is fitted onto a hub, and it's balanced on a flexible shaft. The second part, there's two parts of, there's a turbine and the engine and the rotary engine. So here's the rotary engine, which for the throttle has got this plunger that moves in and out. So when it stops, there's just like a car, there's an idle stop. So that keeps it spinning. And the idle speed is supersonic. Periphery speed, the outer edge. Again, the rotor is shaftless. The exhaust is bigger on the rotary engine than it is on the turbine, and this rotary engine is responsible for lift. So this is responsible for lift, and this is responsible for acceleration. And the engine can be pivoted in the direction of travel. So if you wanted to, hang on, if you wanted to,
Paul?
yeah,
we've gone 1.5 hours already. So yeah, we got to wrap it
okay,
up.
I'll wrap this up pretty quick then. If you wanted to go up, the engine and turbine are pointed in the upper position. The propeller on here isn't real, wasn't needed. The wings again are not needed. This uses air mass rather than air velocity, and it uses gyroscopic precession to create lift along with the air mass being moved. He only put the wings and the propellers in and the fuel tank just to please the patent examiner. So yeah, I'll wrap it up there. There's some more stuff I wanted to go over, but I think we're out of time.
Yeah, I can tell the audience to go to the links that I put on the website for you to go to your interview with Miles Johnston. It's part 1, part 2 with you, right? So there are lots for them to catch up there as well.
Yeah, can I just do one more minute just to wrap it up?
Sure. Yeah.
One of the things I realised was that this twin turbine design is actually a mechanical analog. There's Graham's cold steam nozzle. It's a mechanical analog of his wireless transmission system, and that the wireless transmission system is actually missing the Tesla bulb, and Tesla left plenty of clues to the Tesla bulb that you're all familiar with holding. It says here, the forerunner of the Audion, the most sensitive wireless detector known as described by Tesla in his lecture before the Institution of Electrical Engineers, London, February 1892. I suggest you look up that lecture, look at this here. I'll be releasing this PDF that I'm running from. The rotating brush is the missing, the rotating brush bulb is the missing component in the Tesla coil. It's the part that enables the wireless communication through the earth. This terminal here is the Tesla bulb. Rather than sending a balloon into the upper strata with a wire attached, this bulb has two envelopes of a vacuum of different amounts, and this bulb simulates sending a balloon into the upper strata. And this is the mechanical, so the twin turbine on the flying machine is the mechanical analog of Tesla's wireless transmission system. The twin Tesla coils that you're all familiar with, instead of the capacitive top load that shoots sparks, it should have the Tesla bulb. I mean, this is Tesla's own article. That's from there. These drawings are from Tesla's own lecture. And this was Wardenclyffe, the glass blowing part that was blowing a giant bulb for the top of Wardenclyffe. But yeah, there's some bulbs that I've replicated with a master glass blower for Eric Dollard in America. There's this low pressure superheated steam boiler internals. Yeah, pretty much I'll have to leave a link to this, but Graham has also replicated Tesla's cold steam nozzle from 1935. And so far we've got it to boil water at 60 degrees Celsius using 100 PSI. That was only the first attempt. It's coming over soon to do some more. And there's Tesla's airship for over 1,000 miles an hour. So I'll leave it there. But thank you for having me.
Oh, thank you, Paul. This is so good. Can you stop sharing screen now?
Yeah, sure.
Yeah, thank you so much, Paul. Paul, this is amazing. I mean, it's like at your fingertips, everything about Tesla's inventions, patents. I mean, you shared such a huge, big diversity of resources that you had gathered from his patents. Yeah, indeed, I'm sure you'll be very successful in setting up Tesla's museum, all right? I just wanted to say that to everyone listening and watching, please go to our website and click on the links that I put on Paul Townley's announcement, and whatever reports that I've got on him is on the website, and it's all linked up. And it's got the links for Miles Johnston's basis interview on Paul Townley's work. So go there, click on those links, and you can catch up with a lot more of what Paul has disclosed on his work. And it's really amazing work. It's so exciting listening to you, what you had unearthed. And it's kind of like Tesla was saying to you and in the higher dimensions, say, hey, Paul, go down there, go down there and finish off my work for me. And hopefully you can pull it all out, all those patents, and continue with the good work. And so there you are. Thank you, Paul. Thank you so much.
Thank you very much, Crystal.
Also, Paul, well, this ties in very well. That's why I got you to speak in this session, because Patrick Kelly has been doing your documentation of your latest development, right? And,
sure. Yeah, he started to document the work.
Right, and I mean, he's so hardworking, documenting it until he drops. Oh God, I'm so sorry to hear that. You know, and that it is not completed, right? I mean, it's really so sad that Patrick's gone. He's the best documenter we've ever got for all these inventions and developments, isn't it, Paul? Has he completed the documentation?
Yeah, definitely.
He did.
I agree.
Oh, okay. Okay, right. Over to you, Fres, if you've got any Q&A coming up on your end. Fres, you are the co-chair for this session.
Right. Basically, you've done a lot of improvement since the last time you came in, especially with your bearing system. And to note the shape of the design on the shaft, which you referred to as part A, I think it was on the one with the teardrops in it, and on the air bearing that we were showing had a V pattern in it, and I was really amazed at the difference, and instantly saw the difference in the two of what they would produce as extra support. So I really appreciate what you're bringing forward, Paul.
Cheers, thank you very much. Yeah, it's I did get a quote for some of those foil bearings, the aerodynamic ones, and they quoted me £20,000 to design and manufacture a set. So I went back to the drawing board on that, and yeah, decided I was going to make my own.
Yeah.
And yeah, maybe another day, but it's a lot of money, that is.
What I was wondering is if you could basically surface etch that pattern rather than to machine it in.
Yeah, I think it is actually surface etched. I think you're right on that. Yeah.
I've seen that pattern in a couple other places, and when they were innovative, they were used in silencers for firearms and stuff. But I had no idea that it was part of some of Tesla's work also in early work. So really appreciate it. Paul, I got one question in here that was quite interesting. What do you think about the airships reported in California countryside around 1890s? Was Tesla a member of the Sonora Aerospace Club, which reportedly had access to these flying platforms tech back in 1860? And Solomon Andrew made the electric airship in 1862 and hid their location program in Louisiana.
Well, I think that, you know, airships are a lot older than we realise. I mean, there's ancient hieroglyphics depicting that sort of stuff, and I don't know if he was a member of that at all. But what I do know is that Tesla was studying the Vedic texts, and in the Vedic texts, they described flying machines and flying machines with weaponry that were used for war. And these are all looking very similar to Die Glock, which the Germans, well, I saw a film of Die Glock, I don't know if you've seen that. And it's all using the same principles, moving an air mass rather than air velocity.
Yeah, and do we have time for one more question, Crystal?
Yes, go ahead.
Have you run across Tesla's lights that were used underground in Area 51 that work via a dynamic electrostatic field?
Yeah, I've got the 33 denied patent applications, and one of the patent applications, one of his first ones that was denied, was for a fluorescent tube that basically had no filaments in the end, and it was made from a thicker glass with a higher vacuum, and that was a one-wire or inductive coupling bulb. And the reason that we never saw it is because there's no planned obsolescence. The same reason why we never saw the turbine. You know, no planned obsolescence, and you know, the establishment aren't interested in that.
Thank you very much. Crystal, I'll turn it back to you.
Right. Okay. Okay, can you hear me? Right. Okay.
Yep.
No, I was saying that Marsha and Rovering, they said that they would be in this meeting. I don't know if they're here in this case. Anyway, they were talking. Paul, you knew that they were talking about Otis cars. I mean, Rovering is a living legend himself, and he had developed the craft, the spacecraft flying saucer with Otis car, right? So I suppose, yeah, Otis car being the direct protege of Nikola Tesla. So I suppose you would be investigating from Ralph's work as well, right? Paul, have you?
Yeah, definitely. I mean, Otis Carr and Ralph Ring, I've been aware of for quite some time, and I have studied some of the work, and I can see similarities in what is going on there, but they were doing it electrically, and the neutrons are an interesting shape because, I mean, if you saw the video with the water coming out of that Tesla turbine, where it's coming out both ways, if you put those two shapes that were coming out of that together, you've got the shape of a neutron. It's like a double ice cream cone. So there's definitely some ancient geometry involved in making these machines work. Yeah, like, you know, the pump having the movement from the middle to the periphery, and the turbine having it moving from the periphery to the center, is forming cone shapes. So there's something unique about the cone, and apparently bees, which aren't normally able to fly, have some sort of cones in their wings, and they oscillate at about 200 hertz, which creates levitation because the wing isn't actually sufficient enough to fly like an aeroplane. So yeah, the geometry that's involved in their work's very interesting, and I'd like to spend a lot more time looking at it.
Right. You can get in touch with Ralph instead of reinventing the wheel, because if you remember, were you there in the meeting as well, the last meeting when Ralph was talking about the neutrons, well, you know, they are still, well, you know, it's hidden, and it will be disclosed, it will be brought out in due time. It's just that they were told to be very quiet until it's time, right? So it's there.
Yeah, because he was put in prison, wasn't he? He was framed and put in prison.
Oh, wow.
Out his car. Because he wrote an article while he was in prison about going to the moon.
So anyway.
But I wasn't in the meeting, and I wish I was, but I couldn't make that one.
Anyway. So, Fred, co-chair, that's it, right? You want to wrap this meeting up now? Shall we?
Yes, we can, and I'll let you do the follow-up finish for FESIG, and we'll wrap this up for this session.
Okay, what's on the chat box? Is there anything important that we have missed?
We've got the big ones, and the last one is Paul familiar with Frank L. Reed electric airship reader? There is also the saucer program started in 1920 by Winfried Otto Schumann.
Not one I've heard of, but I'll have to give it some attention now it's been highlighted.
Okay, all of you, please click on the save chat. Save chat.
Elle est vraiment un peu handicapée, la pauvre.
Sorry, Mona. Okay, now,
d'accord.
Pontus, hey, you're an aircraft engineer,
C'est ça que tu crois?
So I mean, Paul is in the mechanical side of things for cars and all that. So you two could talk shop a lot, really, and exchange ideas and all that. Pontus, you want to say anything before we close?
No, it's very interesting, and it's yeah, it's awesome work. Excellent, Paul.
Yep. So
thank you very much.
At some point, if you want Paul to come in to the R&D to help out on certain issues, you know, I guess Paul will be very happy to do that, isn't it? After all, our Graham is there helping you out as well.
Oh, yes.
Yeah. All right.
Yeah, for sure. And Graham, one of your members, has been extremely helpful. He's based in England as well. Yeah. A mechanical engineer that's fully awake and understands how we can move forward to a better world with this technology.
Oh, yes. You're welcome, of course, Paul.
Right. So there being no other business now, this first session of the 79th meeting is adjourned to the second session. So don't go away, folks. Stay, because this is so relevant to the work of Patrick Kelly as well. He's been helping all of us put things together, and it's the best documenter in the world of free energy developments. Right, so thank you everyone for your attendance and your participation, and thank you most of all to Paul Townley for sharing so much of what he knows. So, oh, Graham, there you are. Hey, Graham, kudos to you for helping Paul out.
Thank you very much. You did a great job.
You are a very prized R&D member, Graham. Thank you so much for all that you've done for us and everyone, for humanity, basically. Thank you. Namaste.
Thank you, Graham. Thank you, everyone.
Thank you.